Okay, so this is the EDM geometry that we were talking about last week. I'm going to stop recording again. Okay, so here are the examples that we went over last week. This is the one where you had to put all of this information into your field book. And so the sketch that this is the sketch that we made. And then we said that our instrument was right here. And then we had, let's see, are we looking uphill or downhill at the benchmark?
Downhill.
Down.
You're looking up, aren't you?
You're looking up because that's not a negative, it's a positive. So if that's negative, which the first one was, right? This was negative, I was looking down at the benchmark. The second example we went over last week, it was positive, I was looking uphill at the benchmark. So for this new example, it's a positive 15.74, so the benchmark is up here. Okay. And I'm going to call this this is going to be my prism. And then I'm going to have a prism down here. Okay, this prism is actually the high prism. That's supposed to be straight up and down, trust me. And so the HI is right there. That's an imaginary plane, if you will. And then the vertical distance over here is from here down here, and then here, over to here. And then I'm going to use this as a kind of a reference. Okay. So this is the benchmark right here. This is the sketch that you should have made. Most of you did. Let's take a look at this information. What should the horizontal angle be on my back sight? So what goes there? This would be on all
Zero.
Of this. Yeah, it'd be 0. This would be on your second test. Now, what about here? All these angles, you got all these distances, but there's no horizontal distance for this toe of slope. So what would it be? And it's a trick question. It's a mistake. It's what we call a blunder. The data wasn't taken for some reason, just forgot. I've done it before. Trust me, you'll do it. And so basically that shot is worthless if this was actually part of our topo. Okay. So let's see if we can calculate the HI. And the HI is right here. And the benchmark is right here. Okay. So we start from a point of known elevation. So it's going to be equal to benchmark plus what? Plus the prism height. This is the prism height right here. That's the prism height. Now this HI is not hitting at the benchmark. Some of you made that mistake on your, you had this HI going right into the benchmark. It doesn't happen that way. Okay. Our HI is a little bit above the benchmark. Here, the HI is a long way below the benchmark. Okay. So this prism height right here, is it a high prism? No, because HP is not written there. So it's going to be plus the prism. So that gets me benchmark plus the prism. And how do I get back to, how do I get to HI, which is right here? I subtract the vertical distance, which is 15.74. So that's equal 1720.77 plus the prism, which was 6.78, minus 15.74. So if you run those numbers, 1720.77 plus 6.78 minus 15.74, it's 1711.81. So that's the elevation. Oh, that didn't come out right. There we go. So it's 1711.81. That's this elevation right here. Okay. Now, how do I get the elevation of, say, delta 2, which is my control point? I now know my HI. Am I looking uphill or downhill at delta 2?
Down.
And so it's a negative. So I got to go, I know HI now. I got to subtract the vertical distance, and I got to subtract the prism height. So that's going to be HI. Boy, something's not working right for me. Love the undo button. So we'll do it up here. CP2, delta 2, elevation is equal to the HI, which I know, minus the vertical distance, minus the prism height, but it's a high prism. So that's equal 1711.81 minus, and that's not minus a minus, it's just, it's subtracting that vertical distance, minus 12.68 feet minus the high prism of 12.78. And then that number is 1686.35. Okay, so that's CP2. Now, how do I get this L, even though that's a blunder? How do I get this one? So that's going to be Tove slope. And that's going to be HI plus the V minus a high prism. So plus the V is 12.45 minus 12.78. So here I had, if I wanted an uphill shot, it's no longer the benchmark, it symbolizes an uphill shot. I got HI plus the vertical distance, come across, and then drop down whatever the prism height is. Okay. And then this one, top of bank, I'm looking downhill. So that's HI minus this, which is minus 11.77, minus 6.78, and that's going to be the elevation of that. So what I want done for this week is do this one. Okay? I want it in the field book. So now this will be book assignment for this data. Okay? So you're going to type all of this into the field book, including this, all of this on one side, and then on the other side of the field book is make that sketch. Make that sketch right there. And I want you to show me all the calcs for doing the elevations. You got 3 elevations to figure out. Okay. What's your workload like? What day?
Definitely later in the week.
How about
Wednesday
Thursday?
or Thursday's fun.
How about Thursday night?
Thursday's fun.
Thursday
That-
works.
That way you can ask me questions at the heavy civil Zoom, although actually that's going to be a test, so no, you won't be able to. Tell you what, let's go Friday night because you got that test to study for on Thursday. 99% of you.
So the field book is due Friday.
So I'll put this out as an assignment and I'll give you some more instructions on that. And yeah, that'll be it. That'll be the only assignment. That'll be an easy one. If you draw the sketch and you use the Zoom from last week, because I may have screwed up the Zoom from this week, and use these photographs in relation to the sketch, all you're doing is moving from benchmark to HI via the prism height and the vertical distance. And then once you do that, you either got an uphill shot or you got a downhill shot. Okay? So work those out. We'll give you till Friday at 11:59 p.m. Gives you plenty of time.
Mr. McEgan, could you redo top of bank one more time, please?
Yeah, let me just admit somebody. This one?
Yes, please.
Okay, so that is, since it's negative, it's got a negative vertical distance, which means I'm looking downhill. So it's this part of the sketch. I know the HI. I know the HI. I subtract the vertical distance. Tell you what, we'll put it down here. So the HI is, so this is going to be TOB, elevation. Get rid of these damn underlines and get rid of the bold. So TOB elevation is equal to the HI minus the vertical distance. Okay. The HI elevation minus V minus the prism height. Is it a high prism?
Thank you.
No, is it a high prism?
Oh, no, it isn't.
No. So it's minus P. So that's 1711.81 feet minus 11.77. It's not minus a minus, it's just minus that downhill shot, that downhill vertical distance, minus my prism height, which is 6.78. And whatever that equals. Okay.
Thank you.
Yep. Yeah, this you had for homework. Oh yeah, well here's the notebook. So here's all your notes. And then here's your sketch. Okay, so let's go over that test again in case I messed up the Zoom recording. And then we'll do a little review. So here are the test topics. I'm going to give you C001 and C102, maybe C103. Again, I'll update this during the week. This is for a week from tonight. Survey types, boundary survey, construction survey, a little bit of pipe slopes. The one on the one that we did for the spec house would be a good example. What was the slope of the pipe between the two manholes, knowing the horizontal distance and knowing the drop in elevation. Rise over run. Equipment ID. You got the levels, the two levels. One was the manual level. The other one was the electronic laser level. The electronic theodolite is the instrument that you used for the lab outside of Smith Hall. And then the Philly rod. And the levels in the Philly rod tie into the leveling calculations that were in, what chapter? I think chapter 7. Yeah, chapter 7 is a great place to, that's a great place to study leveling. And
So every field test is Thursday and surveying is Monday?
yes.
Okay.
So that's, and then basic radio layout, and that's where you had right here, right? We use this as our baseline, and then we drew in the sketch, say for this corner. Let's zoom in on this, no pun intended. Okay, so you had this as a baseline. If you wanted this corner, you needed the distance from here to the baseline, and then from here over to here, and that gave you that right triangle. So you had both legs of the right triangle, and then the distance was Pythagorean's theorem. The angle was using right angle trig. So there's no coordinate geometry on this test. But you have a lot of examples from this handout on how to do radial layout. Okay. So I could pick any, I could use this drawing or I could use another drawing, and you just got to set your baseline, and then you literally draw in your triangle, if you will. And then you can get distance is the hypotenuse, and then the angle is off of the baseline. Okay. So that's pretty much it for surveying. Any questions on the, where did I put that? Any questions on the test? And again, I'm going to send you out for both classes, probably by Wednesday. I'll give you directions for the heavy civil test, which is Thursday, and then I'll give you directions towards the end of the week for the surveying test, which is a week from tonight. Okay. So just go through a lot of the homework that we gave you. Have everything in front of you. Have it all laid out, you know, different homeworks based on these topics. Okay. Try to go through and run the numbers, run the calculations on your calculator, studying for it, and you're in good shape. Okay. So let's go to heavy civil. We're right around 7:42. I don't see anybody checking in. Let me know if anybody does check in. I'll let them in. The heavy civil is entirely on masonry. And let me go to my Excel. So it's, you're going to do a little bit of, actually probably a fair amount of estimating and estimating masonry, and a fair amount of masonry identifications. So if you have your textbook in front of you, or you have some of the handouts that I've given you in front of you, you should be in fairly good shape. Fairly good shape. You know, I may ask you questions like, what's the typical mortar joint thickness? 3/8 of an inch, stuff like that, okay? Nothing on concrete. Oh, the only thing you will see that that's related to concrete, but it is related to masonry, is calculating cubic yards and cubic feet of mortar. Nothing on soils. That's going to be test number 3. Okay. So let's go down, just take a look at some of the. So probably a week from tonight, we'll start talking about soils. I may send you something out over the weekend, but you should, in heavy civil, go through these YouTubes and also check out this, it's kind of like a correspondence course. There is no test. They must have taken the test off the web. So just read those first 13 pages. Gives you a really good introduction in for soil mechanics. And then here's your CMU estimating that we did. You've got a lot of how-to PDFs on how to do that. And then also the, you know, some photographs. What's this here? Yeah, I may grab some of these photographs and ask you to identify some of the components. Like, what's that? That's flashing. That's a block backup wall. What's that right there?
Brick shelf.
That's a brick shelf. Okay, so it's a steel angle, bolted and welded back to the main frame. You'll actually do this next semester in commercial. What's this green stuff right here? It's called mortar net, and what that does is catches any of the mortar droppings. It's hard to see, but these little buggers right here are brick ties that are embedded both eventually in the brick with a strap hanger and embedded with a horizontal joint reinforcement in the block. What's this right here? That's the column. So this one's going to be a very basic, very easy test. And the math will be in the estimating portion. Any questions? Hopefully I was still recording. I can't believe I accidentally did that. We're now going to shut down probably part 2 of this Zoom. Hopefully I can grab both videos and combine them into one for YouTube. Otherwise, there'll be part A and part B on YouTube. I hope all of you and your family and your friends are healthy, getting through all this crap going on, and we'll be in touch the next day or two. Take it easy, everybody.
Thank you.